How do machine learning engineers build APIs for AI models? Have you ever wondered how machine learning engineers create application programming interfaces for artificial intelligence models? These APIs allow different software applications to communicate and utilize AI models effectively. Let's break down the process step by step. First, engineers prepare the machine learning model. This involves training the model on relevant data and finalizing it. Once the model is ready, it is saved in a format that can be loaded later for making predictions. Next comes the design of the API. Engineers create a set of rules and endpoints that define how other programs can interact with the model. An endpoint is a specific URL where requests are sent. For example, one endpoint might accept input data for predictions, while another might provide information about the model. Common request types include sending data to the model using the POST method and retrieving information with the GET method. Data handling is another critical step. Input data must be cleaned, validated, and formatted to match the model's requirements. Often, this data is structured in JavaScript object notation format. For instance, if the model is designed for sentiment analysis, the API must ensure that the text is properly encoded and structured. When it comes to implementation, engineers often use web frameworks like Fast Application Programming Interface, Flask, or Django in the Python programming language. These frameworks make it easier to create endpoints, handle requests, and return responses. The trained model is loaded within the API code to process incoming requests and generate predictions. Security is also a priority. Engineers implement authentication methods, such as API keys or token-based systems, to ensure that only authorized users or applications can access the AI model. Error handling is essential too. The API must manage errors smoothly, such as invalid input or server issues, and return clear messages. Successful responses typically include the model's output in a structured format that client applications can easily use. Once the API is built, it is deployed on servers or cloud platforms, making it accessible over the internet. Engineers ensure that the API can handle increasing numbers of requests efficiently, often using load balancing and containerization tools like Docker. After deployment, monitoring the API's performance and usage is crucial. Engineers keep an eye on it to detect any issues or performance drops. They update the model or API as needed to improve accuracy or add new features. Practical applications of these APIs are vast. They can integrate AI models like Chat Generative Pre-trained Transformer for natural language processing, DALL-E or Midjourney for image generation, and productivity plugins that automate tasks. For example, a Chat Generative Pre-trained Transformer API allows developers to embed conversational AI into chatbots or virtual assistants, while image generation APIs enable creative applications to generate artwork on demand. Building an API for an AI model involves designing clear communication endpoints, preparing data, implementing the API with suitable frameworks, securing access, deploying for scalability, and maintaining it over time. This process makes it possible to use AI models across various applications without exposing their internal workings.